If you discontinue watching this video at one point, please tell me what the reason was so that I can improve. Otherwise, hi and welcome. I'm trying to learn particle physics. Today, does antimatter fall up? And after we've done it, we're going to do standing yoga. And if you participate in standing yoga, then it's what you're this. In all the discussions about why matter dominates antimatter in the universe, one unanswered question could turn things on their head: how it behaves under the influence of gravity. Does antimatter fall up? When it comes to the question of whether matter falls down, but technically, if there would be an up and down, would it now go into the other direction? I would say no, because it's just differently charged. Why should it go in the other direction? When it comes to the question of whether antimatter falls downwards under the influence of gravity, as matter does, or asserts its own mirror identity by falling upwards, there are strong suppositions. A huge majority of theoretical physicists, perhaps too huge to be right, believes antimatter falls the same way as matter, says CERN theorist Dragan Hajdukovic. Okay, most of the people saying that if you think about it, antimatter will be drawn towards gravity. That's how on Earth it will fall down. If it turns out that it insists falls up, everything is to play for. It would really turn everything on its head from the instant of the Big Bang, says Jeffrey Hawes at CERN's Alpha experiment. For a start, it means that anyone aiming to explain, could someone make a rocket out of antimatter? For a start, it means that anyone aiming to explain matter's dominance in our universe through phenomena such as CP or CPT violation, I haven't really understood what it was. It was about that there's more matter than antimatter. Such as CP or CPT violation might be chasing shadows. Okay, people who try to explain the matter-antimatter imbalance through CP and CPT shadow could be that they are not able to find a result. If matter and antimatter fall in opposite directions, they probably also repel each other gravitationally. That makes sense. That would mean that we are going away from the gravity and also from the other ones. But they are they mass? Is antimatter massless? Why should it be? In that case, they could have, if they have no mass, they are not pulled in by gravity. So they have a mass. In that case, they could have chased each other away to opposite ends of the universe before having a chance to annihilate each other. It seems like matter and antimatter for some reason wants to annihilate each other. 1 plus wants to go together with a -1, or even the neutral one goes together with another neutral one. And now the idea is, if they are being like a magnet pushed away from gravitation, antimatter, then it would be that because matter and antimatter have mass, they are pushing each other away. No. Would they not chase each other? They could have chased each other away to opposite ends of the universe. They now say that they have repelled each other together. What I don't get is, if matter falls down towards gravity, and antimatter is gravity and falls away, then the antimatter is falling away from the matter. But the matter is falling towards the antimatter, and is therefore following the matter. And where we have our machine which runs forever. It just follows forever itself. Probably making some mistake, because why should we have mixed up with falling and repelling? That puts the option that antimatter is just hiding, now lurking behind the horizon of our observable universe, back on the table. Okay, one of the idea is, there is enough antimatter for every matter particle, there is no imbalance, but the antimatter is very much at the other end as the matter of the universe. You could potentially imagine that matter and antimatter early on have completely separated because of some anti-gravity, says Chloe Melbourne at CERN. The electromagnetic force is far more potent than gravity on small scales. So to measure how antimatter responds to gravity, we need anti-atoms to be electrically neutral. They have to be electrically neutral, otherwise we would have an electromagnetic field on each other, and that would be overcome, that would be much stronger than the gravitational influences on each other. The trapped anti-hydrogen atoms that the alpha experiment has been able to make since 2018 are ideal. So they have anti-hydrogen. Shortly after that breakthrough, the team activated plans to essentially tip their horizontal trapping apparatus at right angles to function as gravity detector, dubbed alpha G. I think they just wanted to turn this thing around. I'm not completely sure what that was, but that must look something. The team should be able to test at once the improved ELINA system for making anti-protons comes on stream, planned for 2022. Another detector that Marlboro Nord is working on, AEGIS, and the third experiment, GBAR, are also gearing up to confirm whether antimatter falls up or down, and also answer the much more fiddle question of whether matter and antimatter feel the same strength of gravitational force. Okay, they are shortly before being able of turning their machine upside down, and if they have done it, we could see if a matter falls up or down, if it goes like air bubbles and water up, or like a stout falling down to the ground. I don't get it completely. And the other thing is, we also want to know if it is a strong amount of gravity down to the ground. No, I can't get it clear anymore. It doesn't matter how heavy something is that is pulled, not with the same force, but with the same speed. Is this that? Is it that with an iron ball falls as fast as a wooden ball? No matter how heavy they are, because they have the same air resistance, because they fall the same, but they don't have the same gravitational force. That is why the one is heavier, but they fall the same speed. I think that is it. They fall with the same speed, but the one is heavier because it has more mass. So it could be that gravity falls maybe with the same speed or falls up with the same speed, but it could be still done being pulled stronger up or down. But has been still the same speed. Any deviation from expectations would have huge repercussions. I don't know what repercussions are. It would be a big thing if there would be something other than, and most people believe, antimatter falls the same way as matter. Hajdukovic has shown how the existence of two opposing gravitational charges would allow the quantum vacuum itself to become a source of attractive and repulsive gravitational effects. Let's just read it again. So, Hajdukovic has shown how the existence of two opposing gravitational charges. What is a gravitational charge, and what would be the opposite of it? I don't get it. Would allow the quantum vacuum itself to become. How? Now, what is a vacuum? A vacuum is a thing where nothing is entering. And a vacuum wants to pull everything to itself, I think. And in that thing, it would be a quantum vacuum itself to become a source of attraction. So it would not try to pull the things to it because there's a vacuum. Would the vacuum attract itself? Become a source of attractive and repulsive gravitational effects. Let's just read on, maybe we're confusing two things. That might account for both why there seems to be a lot of gravitation stuff out there that we can't see. Dark matter. Okay, dark matter has gravitation. We're saying it here. And the mysterious force that seems to be speeding up the why is the universe expanding? What is this antimatter and matter which are repelling each other? That might account for both why there seems to be a lot of gravitating stuff out there that we can't see, the dark matter, and a mysterious force that seems to be speeding up the expansion of empty space, which we call dark energy. Empty space is expanding. And the thing is called dark energy. Okay, black holes sucking in matter could then also be white holes spewing out antimatter. Maybe on the other side, or we're saying we're saying the same ones, but maybe there's a different kind of them, like stars and white stars. So a different kind of black holes, whatever. Maybe it's on the other side. On the other side, maybe there comes out the antimatter. Or it's a different one, different black hole, which is not sucking in matter, but spitting out antimatter. Hajdukovic says the possible new source of antimatter could explain strange excesses of high-energy positrons and antiprotons observed in cosmic rays. Okay, there are strange excesses of high-energy positrons and antimatter observed in cosmic rays, as well as very high-energy neutrinos seen coming from our galaxy center by the ice cube detected in Antarctica back in 2014. Okay, they seem to find in some places an excess amount of positrons. Positrons are the antimatter things of electrons. Okay, they're finding at some places too much antimatter, too much positrons, and at other places they measure too many antiprotons, so the opposites of the protons, in cosmic rays. For example, from the center of the Milky Way. There are too many antimatter positrons, antiprotons. The existence of two opposing gravitational poles might even lend weight to the idea that the Big Bang wasn't a beginning, but the latest in a series of cycling matter and antimatter universes. Antimatter gravity experiments might be much more than a measurement of the gravitational acceleration of antimatter. They might open a window towards a new physics and new model of the universe. Imagine that way someone would create new physics. Imagine someone can create new physics with one of these CERN apparatuses or something, not just accelerating some atoms and letting them bang against each other, but being able to create a new universe with new physical laws. I mean, imagine what someone could, for better or worse, do with it. More for the worse, but what would be done with it? The existence of two opposing gravitational poles might even lend weight to the idea that the Big Bang wasn't the beginning, but the latest in a series of cycling matter and antimatter universes. That was the particle physics part. If you were here for particle physics, you can go direct to the next part of particle physics. If you stay here and participate in the standing yoga, then it's better at your own risk. We're having just 2 minutes. We're having the feet standing together and we're breathing in and lifting the arms up. And breathe out and lift the arms again out. If you participate in this, then at your own risk. Breathe in the arms up. Out and down. In and up. Out on to the side. In and up. Out on to the other side. In and up. Make an inch of space between the feet and up again to the side. In and up, come up onto tiptoes. And breathe out, sink a bit down. Let's hang out a bit under the knees. Stay on tiptoes. In and up again. Out to the other side. Heels down. In and up onto tiptoes. Out and a bit down. In and up. Out, down, arms over the sides, down. Breathe in, then the right hand. Breathe out, stretch your left foot. Breathe in and change. Up the right foot. In and change. Left foot. In and change. Right foot. In and middle. And out. Breathe in, lift the right hand. Up. Breathe out, bend the left knee. Look over the right shoulder to the right hand. Inhale down. Up and down. Breathe in, left hand up. Out, bend the right knee, look over the left shoulder to the left hand. In and down, out and down. Breathe in, straighten the back, halfway up. Out and down. In, straighten halfway up. Out and down. In and up. And lean back, draw the shoulder blades together. In and up. Out and back, draw the shoulder blades together. In and up. Interfering fingers, reach high, breathe in. Breathe out, reach front of the back. In and up. Now cross your arm very round. Breathe in, reach high. Out, reach in front of the back. In and up. Out of the long arms back. In and up. Out and back. Out and down. In the arms up. Out and down. In the arms up. Bring the hands to touch, allow the hands down to not Antimatter. That was the Senor. I thank you very much and until next time.